Okay, today is the 19th of February 2024, and this will be our third video on cumulative frequency and its interpretations. And today we'll add the box plotting as well. Okay, thank you everyone who have subscribed, helping us share, liking and following us. Thank you very much. I appreciate it a lot. Okay, and if you haven't done so already, can you please consider it? And if the account is not yours, please ask permission from the account holder, or open your own account and then you can use it to subscribe. Share also, guess few months down the line, some people are going to take their exams and they would need the extra help. So please share, subscribe, like and follow. Okay, in the comment section I normally write, please follow my notes / scripts. I've just finished preparing the notes, okay, and I have gone through several times to make sure that I'm giving you the right information. But at times I might be trying to say less than 24 and it comes out as like 24. So for instance, if my pen is pointing here, add less than 24. Don't just think it's 24, because in maths, less than 24 is different from 24, exact 24. So please follow the pen and follow my notes. Okay, I will appreciate that a lot. Now, beware of scammers. Okay, beware of scammers. Okay, if everybody is a victim of that, they will call you on numbers, no numbers. You can't call them back. At times to call you on a number, you call that number and it says it doesn't exist. Okay, some of these are scammers. Immediately they start sending you foreign numbers. Block it or just be on guard. Okay, it's better not to return the call than to return it and then realize that all they wanted was access to your to account or something. Okay, so just be vigilant on that. Okay, we are all victims, so please be vigilant. If I haven't said it on this video, then it's not a fact, and actually I'm not using this platform for that. Okay, now watch last video for recap. This will be our third video on cumulative frequency. So I have the intro and I have a second video. Okay, today I'm just going to look at a graph work, help you plot do a box plotting and a cumulative plotting. Okay, emphasize what we did last video, and then we'll come back tomorrow and see what we'll do next. Okay, now I've just talked about recap. Okay, Our starter is revision because we had a few days break. Okay, so we've been talking about frequency. Okay, and cumulative frequency, sorry. Okay, it's like a running total. Okay, um and then we use upper boundary of each group data to plot. Okay, so we don't use the lower boundary. So if the interval is between 0 and 10, you are going to use 10 with the corresponding cumulative frequency to plot. Okay, we did a plotting last lesson, but I'll do another one with you this lesson. Okay, remember to accumulate data. So you've been given the frequency, but you might have to find the cumulative frequency. Okay, which we did last lesson, but we'll do it again. So if you haven't watched last video, go back and watch, but you have a chance of seeing us do it again. Now the cumulative frequency curve, this curve here, okay, that is how it is. It's also called the archive, this one. That one here. Okay. It's also called the archive. Okay. That one here. And we'll discuss it in a bit. Use the graph for interpretation, such as estimated median, okay, lower quartile, upper quartile, interquartile range. Okay, these are things that you need to use your cumulative frequency for. Okay, the group data can also be used for box plotting, and also known as box and whisker plots. Okay, where you be asked to find use the lowest value and the highest value and the lower value. So with the box plot, you need a lower value and a highest value. If I'm not being given, then I'm just going to use what I have. I'll go by what I have on the group data. Okay. The lower quartile, which you can find on your archive or your cumulative frequency curve, the upper quartile and the median. Okay, and the difference, okay, the values you get for the lower quartile subtracted from the highest value, the upper quartile, will give you the interquartile range. Okay, I hope I'm making sense. Now, today, the question we have here, the example we have the sizes of 80 watermelon given below. But look at the data that we've been given, okay, because in the end, we are going to use it for the box plotting as well. To do the cumulative frequency is alright, because we just have to go by the upper value here. Okay, so this is our cumulative frequency. Okay, we've been given this table, these two column here, this one and that one, and we have to complete it. So to do a cumulative frequency curve, you need the upper limit, so less than 4, less than 8, less than 12, less than 16, less than 20, and less than 24. So I'm going to plot on the 4. I'm going to plot the cumulative frequency of 8. So this will be one coordinate. 8 and 35, 12 and 56, 16 and 72, 20 and 79, 24 and 80. Okay, then after that I'll use my free hand to draw the cumulative frequency curve. Okay, you can't use a pencil, it's a curve, so you need to use your free hand and draw. That's why you are going to get estimated answers like the median. But if the answer is 21 and you got 18, that means you didn't plot it well. Okay, if the answer is 21, you should be getting like 20.8 or 20.5 or 21.5, depending on the scale you use. Use a scale that you can easily read. Don't use weird scales, okay, that you have to struggle to read. Okay, so that is one of the things I will say this morning. I think I've said it before. So complete the table. We've done that. We've just completed the table. So this is our upper frequency here. Okay, and that's the cumulative frequency. So our upper limit 4, 8, 12, 16, 20, 24. These values are going to go on the x-axis. Okay, so and they are in kilograms. So whatever I put on the scale I use on the x-axis, I have to make sure that it's up to 24 or 25. Now my cumulative frequency is 18 watermelon. So at the end, my last figure should be 80. But what I'm going to, the cumulative, these are the frequency. So between 0 and 4 kilograms, there are 8 watermelon. Okay, so 8 at 27. So the first cumulative frequency figure is 8. Add 27, you get 35. Add 21, you get 56. Add 16, you get 72. Add 7, you get 79. Okay. Add 1, you get 80. So normally these things, they don't even come in the calculator paper because you can easily add them. Okay, so this is the table again. Okay, I've completed the table. So I've done the first part. Now, draw a cumulative frequency graph, okay, which I've done. So when it is 4, so look at my axis again. The x-axis should be up to 24. So I have 5, 10, 15, 20, 25. Do it such that it's easy to read. So that'll be 2.5. That'll be 7.5. Okay, that'll be 15. So it's easy to read that way. So I'm going to draw, and then on my cumulative frequency, look at what I've done. I have 0, 10, 20. Every 2 boxes, sorry, is a 10. Okay, because I need it up to 80 because I have 80 watermelon. Okay, I have a title here. I've labeled my y-axis cumulative frequency, and I've labeled the x-axis the sizes in weight. And then a title of cumulative frequency against the sizes of water. Okay, that will be my box plot here, which I'll explain in the next session. Okay, use the graph to find the estimated median. So the median is half of the cumulative frequency, which is 50%. Now the total cumulative frequency is 80. So half of 80 will be 40. So you come to the graph, your y-axis, that is the 40. Try and join it to the curve that you've drawn, and then find the corresponding value here. Okay, so if you look at the graph here, it's about 9 kilograms, because that is 10, that is 7.5. Okay, so if you look at it, it's about 9 kilograms. So I've circled that. No, sorry, the 40 is here. So if you look at it here, okay, it's about 9 kilograms here. That is a different thing. Okay, that one, this is about 9 kilograms here. So my 40 to the cumulative curve, there 9 kilograms. Okay, because each box is 1. So if I count backwards, that is 9, that is 7.5. So your 9 shouldn't be here, that is here. So the median is 9. Now they ask us to find the interquartile range, and the interquartile range is the lower quartile. Okay, you find the value and then you subtract from the upper quartile. The lower quartile is 1/4 of the cumulative frequency, and here again the total is 8. 1/4 will be 20. Okay, so you come again here, 1/4 to your curve that you've drawn, and then when you go all the way down here, okay, this is the value you should be reading. So here again, this is about 6¼ kilograms, or 6.25 kilograms. Okay, and you can get a weight of 6.25 kilograms. So now your lower quartile from here is 6.25, which I got here as 6¼ Your upper quartile is 3/4 again of the total watermelon, which is 80. So this is your upper quartile here. That is 1/4. Okay, that is 40. So 60 here. Okay, is the upper quartile. Okay, I will write it later. So if you join it to the curve and you come all the way down, here again you have about 13¼ or 13.25 here. Yeah. Okay, so if you count it, it's about 13.25. Now you need to subtract 13.25 from 6.25, or 13¼ kilograms from 6¼ kilograms. So if you do that correctly, your interquartile range now is 7 kilograms. Okay, so you are getting values that can do your box plot now. Now draw a box plot. Okay, and then you on the graph, on the same graph. So what I did was, I already have the values, so I use my pen to draw the box plot on here. So here I am here. Okay, so this is my box plot. So if you can see from the values I've just discussed earlier, okay, I just extended it. So this is my lower quartile, okay, there, which I've already found, okay, just by extending the line, and I draw it. That is my median here, okay, there. If you look at the long ruler and take it down there, that's the median, and then that is my upper quartile, okay, there. Now I need the lowest value. In this question, I haven't been told, okay, so the cumulative frequency, if you look at it, is up to 80 watermelon, and it's up to 24. So I drew the line to 24 here, okay, that would be the highest value. But it can also, because it's a range, it could also mean that the highest weight of the watermelon could be, let's look at the table again. It could also mean that the highest weight was 23, but I haven't been told. So I've just extended the line to 24 for the the range, and then here I've extended the line to 0, because technically if it's 0 then it's none, but it could also be 1, but I haven't been told. But it says just draw a box plot, and because we are learning how to draw a box plot, that is why so what I did was, that is the interquartile range. These are the figures, and that's the median, okay. These are the estimation from the graph. So I extend it to here. If I extend it to 4, it could also mean that because it's between 0 and 4. So what if it is 2.5 or 2 1/4? I haven't been told. So I've just, because of our learning, I've just extended it. But assuming they were giving you an exam question, they will either draw it for you, and then you can thank you, you can get those figures from the graph, or they will specifically word it such that you will be able to deduce the lower and the upper ranges, as we saw in one of the questions we did. Okay, so this is my box and whisker plot. I have a graph, and this is my my cumulative frequency curve, or my ogive, okay. Now the last part of the question, which helps you interpret the graph, okay. So we've drawn the box plot, we've done that. So now use the graph to have how many watermelons are between 5 and 11 kilograms. So we go on the x-axis. If you look at 5 kilogram on the x-axis here, okay, and you go up the curve I've drawn here is about 13 if you use the scale that I've used, because that will be 15, so that will be 12.5 or 13. Now it's watermelon, so I can't really put it as 12.5, so I put it at 13, okay, because that will be 15, so that should be about 13. And then 11 kilograms here, so I go up, and that is exactly 50. So between 5 kilograms and 11 kilograms there, if I draw all the line, I have 50 kilograms, okay, and I have 13 watermelons, and I have 50 watermelons. So if I take 15 from 13, then I have 37 watermelon. So guess by using the graph and its estimation, I can say that there are 30 watermelons, which has a weight between 5 kilograms and 11 kilograms. Okay, so that is how you can use cumulative frequency curve to interpret the data you've been given. Because if you look at the data here, okay, and look at the first two boxes here, there is no way that you can know that. But after plotting the cumulative frequency curve, now you have some figures to work with and to find what they're asking you to find just by plotting the graph. Okay, and then with the box plot, as I said, this extended whiskers that are here, they might give you the figures, but because I don't have the figures, and and I can't start from 4, okay, because it said less or equal to 4, so it can also be 1 kilogram, but I haven't been specifically told. So that is why I started just about 0 here, and then the last one, 20 to 24, it could be between 20.1, okay, to 24, or the biggest could be like 23.8. I haven't been specifically told again, so guess for the sake of our learning and for me to show you how a box plot looks like, okay, which we've done in one of the questions. This is so the median, that is my lower quartile, upper quartile, and then I extend it to the lowest value, okay, of the upper limit and the lower limit, okay, but I got the median, which I already plotted here, so I had to just extend the line, the lower quartile, so I had to just use my ruler and draw this line, the upper quartile, extend it upwards. So on these two graphs we have the box plot here, and then we have the curve here that we've drawn using the table we've been given. Okay, so you can also get a graph paper and draw your own curve using this data. Okay, try and make it freehand as possible using this data here. the table that I've completed. Normally they'll give you the first two, and you will have to use the upper limit and find the cumulative frequency, which I've just revised with you in the starter. Okay, if you haven't subscribed already, please can you subscribe and share with your friends as well. Okay, thank you so much. Thank you so much for joining me today, and I'll see you in the next.